Dear students, welcome to the topic View of Data in this database management system. The session outcome is to explain the various views of data in a database system. Let us see what is meant by a view of data. First, a database system is a collection of interrelated data and a set of programs that allows the user to access and modify these data. So, the related data are put together as a collection which you call it as database system. Together with that, you should have some programs that helps you to access those data and also to modify these data. For example, if you have a student database, only the data related to the students will be stored in that particular database, and you have some facilities to access the set of student data and to modify these data. That is what you call it as a database system. You have a collection of interrelated data and programs which we use to modify these data. And the major purpose of a database system is to provide users with an abstract view of data. This is more important for a database system. It provides an abstract view of data. That is, the system hides certain details of how the data is stored and maintained. It will show you what is the data stored in the database, but it will not show you the details of how this data is actually stored in the database. That is what you call it as the abstract view of data. We'll see more about this data abstraction here. The need for efficiency in the database has led to the designer of all these databases to use the complex data structures to represent data. When we move for this complex data structure, you can efficiently store all these data in efficient manner. So, this has led to the designers to use more complex data structures. And the developers hide this complexity from the users who are using these databases, because the users need simple interaction with the system. Only then the users will be familiar, or they will be eagerly using the system. When they have complex interfaces, they will be reluctant in using this system. So the developers hide the complexity from the users. So for this, we have three different levels of user abstraction, that is data abstraction. The first level is the physical level, where it shows the data which are physically stored in the databases. So this is the physical storage of the data. And above this, you have the logical level. This will hide the physical details, and this will show what is the data which is stored and how it is stored. What is the relationship between the data. That will be shown in the logical level. Above this, you have the view level, where you have different views of the database. Each and every user will have a different view on the database in this view level. All these put together, you have different views of the data. First, let us discuss about the physical level. This is the lowest level of abstraction, which means that there is no hiding at all here. So this describes how the data is actually stored in the database, and this describes all the complex low-level data structures in detail. So this level is for the developers to use it. So they'll see what is the data structure which is used for storing the data, and this is the lowest level of abstraction. The next level above this physical level is the logical level, which is having some level of abstraction, that is, some details are hidden, like what is the physical storage that is hidden, and this describes only what is the data which is stored in the database and what is the relationship that exists among these data. That is shown in the logical level, and this describes the entire database in terms of small number of simple structures. The complex structures are hidden, and this shows only small number of simple structures. The user of this logical level does not need to be aware of the complexity of the underlying data structure. So he will not be known about the underlying data structure. So this is called as physical data independence. You are not dependent on the physical data. You are not aware of the physical data, how it is stored. Usually, the database administrators, they must decide what information to be kept in the database, and hence they are the users of the logical level of the abstraction. Physical level, it is up to the designers, and logical level, it is up to the database administrators. The next is the view level, which is the most important level, which describes the performance of the database, and this is the highest level of abstraction, and this describes only a part of the entire database. Not all part of the database is shown at this particular level. Even though the logical level uses simple structures, complexity remains there because of the variety of information stored in that particular large database. So even the logical level has some complexity which is being hidden in the view level. Many users of the database system do not need to see all the information. They need to access only a part of the database. So example is like in an organization, only the payroll processing users have to see the financial information, and the academic users need not see this administrative part, and the administrative part need not see the academic part. So the data which has to be seen depends on the role which is being played by the user, and this is being provided with the view level. The view level of abstraction exists to simplify their interaction with the system. This simplifies the interaction of the user with the system, and the system may provide many views for the same database based on the user and their role. Consider an example. You have a instructor having a record, and he is having ID, name, department name and salary. You have an instructor in an organization who is having a unique ID for this instructor to being identify the instructor, and name of the instructor, and the department name in which the instructor is associated, and what is the salary of that particular instructor. So for this, it is a university database which is having several records. Like this is one particular record. Instructor is a particular record, and you have department record, student record, etc. that stores the data of the instructor, department and student respectively. So this particular code defines a new record type. This defines a new record in the database called as instructor, which is having 4 different fields. The 4 separate data of the instructor are being stored here, and each of these fields have a separate name and a type associated with it. So what is the data type of ID? That is character, which can hold up to 5 characters. Name is a character type which holds up to 20 characters. Department is also the same kind, and salary, it is a numeric type. It is having some floating value that we'll discuss during the deep study of this. So at the physical level, an instructor, department or student record, it can be described as a block of consecutive storage locations. At the memory level, how this instructor, department and student are stored, that is described at the physical level. So the compiler will hide this level of detail from the programmers. So only the developers will know about this physical level and how it is stored. The next level is the logical level. Each such record and the interrelationship between these records is described by a type definition, and programmers using a programming language, they work at this level of abstraction. So this physical level is up to the developers, whereas this logical level is up to the programmers, and with the help of programming languages, they work at this level of abstraction. The next is the view level. Computer users see a set of application programs that hides the details of the data types. They will not be able to know what is the type of the data, and several views of the databases are defined, and a database user see some or all of these views based on his role in the database. So this provides a security mechanism for the databases. So based on the role which is given for a particular user, he will be able to access that particular part of the database. All users cannot see all the data. They'll have some security levels provided by the administrator. Based on the level, they can view the data in the database. So this provides a security mechanism for the databases. Then you have the instances and schemas. So you are storing some data inside the database. Consider a student database. Suppose that you have 10 students for a particular department at a particular point in time. After this, the student may get included or he may get deleted. So based on that particular time only, we'll have different information. So the databases changes over time based on the information which is inserted and deleted. The collection of information stored in a database at a particular point in time is called as instance of the database. So this varies over time. When a new user is added, you'll have a different instance, and when a user is deleted, you'll have a different instance, and this instance changes frequently. Whereas you have an overall design of a database which is called as a database schema. The design of the database is called as database schema, and this design will not change frequently, and hence the schemas are changed infrequently. The instances change frequently, whereas the schema will not change frequently. That is the difference between instance and the schema. Database schema, you have a physical schema which describes the database design at the physical level. You have a physical schema to represent the design at the physical level, whereas you have a logical schema that describes the database at the logical level. So you have different levels of abstraction, and for each level you have a schema that describes the design at that particular level. And a database may also have several schemas at the view level. When you have more number of view levels, then you have more number of the schema at this view level, which is called as sub-schemas that describe the different views of the database based on the view. Of these things, the logical schema is by far the most important because it gives the performance based on the level, and hence this logical schema is having more importance in terms of effect of an application programs. The programmers construct application by using this logical level only. So based on this logical level or the schema, the programmers construct the applications, and these applications access the data which is stored in the database, and hence this logical schema is far more important. The physical schema is hidden beneath this logical level, and this can usually change easily without affecting the application program. This is because you do not have any dependency between the application program and the data which is actually stored in the physical schema of the database. Since there is no dependence between this application and the data, you can easily change whatever you want without affecting the application program. The physical level schema can be changed without affecting the application program. This is the independence between the physical level and the application program. Application programs are set to exhibit the physical data independence if they do not depend on the physical schema, and thus need not be rewritten if the physical schema changes. If the schema changes, there is no effect on the application program. This is the independence between them. Summary. In this video, we have discussed about the various views of data. So the view changes based on the level of the user, and we have three different levels of abstraction. That is physical level, which is at the lower level, that has the physical storage of the data. The logical level, which represents what is the data stored and what is the interrelationship between the data. And we have view level, which changes with the user. And we have instances and schemas, where the instances change frequently, whereas schema, which is the design of the database, that changes infrequently. So this is the reference book, which is your textbook, Database System Concepts, 6th edition. Thank you.